Today I want to give you some insights how we created the augmented reality multiplayer game in Unity, which is currently on Kickstarter. If you like what you see, of course, I would be very grateful for any kind of support. There's a lot I learned about Unity, augmented reality and networking that I think will be very helpful to you, even if you don't plan on creating a Mario Party-like game in augmented reality. Before we dive in too deep, the idea is pretty simple. Let's use the core gameplay of Mario Party, so a meta game that is tabletop-like and minigames between each round, but in augmented reality. This means you can play with your friends without requiring a console. I mean, everybody has a smartphone. Augmented reality makes the game really fun as you can walk around the playing field and it feels like a board game, just in a realistic way. Again, if this sounds fun to you, check out the Kickstarter link in description. I really appreciate it. We have put our hearts into the game for a long time. Let's get into the interesting technical details. It is completely built in Unity. There's a really interesting challenge when it comes to augmented reality multiplayer games. Because even if you are in the same space as your friends, the devices don't know that they are in the same space. They each build up their own representations of the world, creating their own coordinate system. So the 000 on one device is different than the 000 on the other device. This is really tricky and core to the gameplay of AR Party. There's an official solution to the problem, which is called Cloud Anchors, a service provided by Google, though there are also solutions provided by Microsoft and others. Those services work by a device sending their scan data, something like a point cloud, to the Google servers. And then each device downloads them and compares them to their own scan data, hopefully finding some similarities, therefore allowing a synchronization. This sounds great, and it is somewhat great, especially for use cases where I place something somewhere in a city and then somebody comes along at a later date, then seeing what I placed. But it requires an internet connection. It takes quite a long time to upload, download, and compare. The scanning done beforehand also has to be done very careful, and even then it failed way too often in our experience. So, yeah, we're stuck. We thought, just from a logical perspective, it always seemed like there had to be a way to do it when all smartphones are in the same room. There's just one variable missing. After a lot of research and a lot of thinking, it became clear. The variable missing are the other devices. If my device knew where some other device is compared to my position, you can easily calculate the difference between our coordinate systems. So it turns out the solution is actually quite simple after you wrap your mind around it. You display a marker on one device. All other devices scan it, meaning they now have collected the missing variable, the position of the other devices. Another core insight cropped up while developing the game Target Shooter. You have to walk around the playing field and hit more targets than your friends to win. We really thought it would be cool to see the other players' guns appear in front of their smartphones, especially for some future version where you play the game remotely. Seeing the movement of the other players gives a strong sense of presence. We built up the game to work with a classical client-host system in mind. Of course, this is a well-tested and logical way for networking. But there's an implicit assumption in there that at least we made that all traffic is between hosts and clients and not between the clients themselves. This works out fine most of the time. The host controls the main game flow and runs all the calculations. That's great and simple. No disagreements about the game state can appear as the host acts as a single source of truth. Cool. Still, it means when the devices, for example, share their position, client A can't just talk to client B. Client A has to talk to the host, who then talks to client B, doubling the latency if the communication is one-way, and quadrupling the latency if it's two-way. That's no good. It sounds obvious, but it's something we hadn't took into consideration and had to add in midway. The key insight is that there are things in the game depending on each other, requiring a single source of truth. For example, when two players shoot a target at the same time, both may register the hit on their end, so this logic is left to the host. This way the possibility of a disagreement is eliminated. But the insight is, there are also things that don't depend on each other, like the position of the guns, because in our case they don't collide and a small offset in the position doesn't really matter. I hope you found these insights somewhat useful. They were an important part in creating the game. So, without further ado, I present to you AR Party.
Hey everybody, this is Robin, my name is Seppi, and we're proud to share the game we have been working on for the last year. The world first AR multiplayer party game for mobile devices. And we're planning to release this game without any ads. To make this possible, we need your support. If you also believe this is how the future of mobile gaming should look like, support us. We believe that augmented reality can combine the best traits of physical gaming and digital mobile gaming.
The goal is simple. Collect more trophies than your opponents. You can buy trophies for 10 coins, just like I did right now. Oh yeah! By winning minigames, landing on coin fields, or using items, you can collect coins. Speaking of minigames, after each round, a new minigame starts. We thought about how we could transition between scenes in an AR world without the ability to cut or move the camera. This is what we came up with. The game starting right now is target shooting. Yes! You have 30 seconds to hit as many targets as you can. You can walk around the playing field and aim with your smartphone just like magic.
We have many more games in store, like Dung Beetle, Treasure Hunt, Scrapyard, and The Floor is Lava, where you have to work together with your friends to cross the burning workshop floor. One player places blocks and the other jumps on them to reach the opposite side. Be careful though, your opponents can also use your blocks to gain an advantage or use their blocks to block your path. These are just some examples of many more 2 vs 2, 3 vs 1 or free-for-all games we have in store. Look down below for more information.
Our goal was not only to create a game, but to create a world. The game master of this world is Wallet Guy, a coin-hungry tinkerer. To satisfy his endless hunger for more coins, he created a game to trick the sofa guys to collect more coins for him. The sofa guys are little collectors eager to win against their fellow peers. I wanted to create a character that was lovable. It started with sketches, but over time it got more refined. I created a 3D model, materials, textures and animations to bring this character to life. We really tried to create something that you will love.
This is how it will look like, playing with your friends in the middle of the room. We have built a strong foundation, how to finish the game and implement all the missing features, items and minigames. We need your support. Become a backer to get early access, be a valuable tester and part of the creation of AR Party.
Become a backer if you want to see this new way of gaming with your friends become a reality.